This video is an overview of the various types of financial problems in Chapter 6. Let's begin with simple interest. Suppose you've borrowed $10,000 from your uncle and he's lending it to you at an interest rate of 5%. So that's $500 in interest each year. And if this is for 2 years, then $500 times 2 years is $1,000. So the general principle is that the interest is the principal times the rate times time. So in 2 years, we owe Uncle $1,000 of interest, but we also owe him his money back. So 10,000 plus 1,000 principal plus interest is the total future value or accumulated amount. So future value or accumulated amount is principal plus interest. And using our earlier formula, that's P plus PRT, or factoring that out, P times 1 plus RT. Let's talk about compound interest, where this pattern repeats. So for example, Sarah has invested $5,000 in an account that earns 6% annually. The compounding is quarterly. So P times 1 plus RT, P is 5,000, 1 plus R is 0.06, T is 1/4 because it's 1/4 of a year equals each quarter. And so at the end of the first quarter, Sarah's balance is $5,075. Now in the second quarter, Sarah is earning interest not on $5,000, but on $5,075 because her interest from the first quarter is earning interest. This is the power of compounding interest. And so not $5,150, I've earned an extra $1.12 in interest on the interest. And this pattern continues. In quarter 3, we earn interest on that balance to give me $5,228.39. And at the end of the fourth quarter, we've got $5,306.82. Now, do I need to do this 8 times to see where I'm at after 8 quarters? No, because the pattern is clear. We start with $5,000 in principal, and each quarter we multiply by 1 plus RT, or 1 plus 0.06 divided by 4 in this case. And if I'm going to do that 8 times, remember, exponents mean repeated multiplication. So multiplying by this quantity 8 times looks like this. And so we find at the end of 8 quarters, the balance is $5,632.46. So in general, the general formula then is we start with our principal and we multiply by 1 plus RT, or changing notation a little bit here, T is 1/4, M is 4 if things are quarterly, and we multiply this n times. So my exponent is n here, where n is the total number of interest periods. Annuities. The difference here is that this is not a one-time investment. This is an ongoing payment. Will is going to make a $3,000 payment every year, not just at the beginning of the problem. That's what makes this an annuity. Okay, so what's the pattern here? At the end of the first year, the deposit's made at the end of the year. So at the end of the first year, we make our first deposit, and it has not had any time to earn any interest. At the end of the second year, though, that $3,000 that we deposited has had time to earn 6% interest. But don't forget, Will is depositing $3,000 every year, so I need to make sure I add in this new payment of $3,000, giving me a total value of $6,180 at the end of the second year. During the next year, that $6,180 will earn 6% interest, and we're also going to deposit an additional $3,000 at the end of the third year, giving me a new balance of $95.50 and 80 cents. The pattern continues in the fourth year and at the end of the fifth year. What about mortgages, loan repayments? For example, you see here what Bob has borrowed. Bob here has decided not to make the minimum payment. Instead, he's paying $1,500 each month. So in our amortization table, let's enter that as the payment to be made each month. In this case, the interest is 4.98% times the outstanding balance, which initially is $210,000, divided by 12 because we only owe 1 month interest at this point. And so $210,000 times 0.0498 divided by 12 is $871.50. That's how much interest Bob owes the bank after holding this loan for 1 month. So of the $1,500 Bob is paying, $871.50 of that is just going towards interest. The remaining balance, which would be $628.50, right? I take $1,500 minus $871.50 and get this number. This is the money that's actually going towards Bob's balance. This is what's actually reducing the amount of his loan. So we started at $210,000. We're subtracting $628.50, which leaves a new unpaid balance of only $209,371.50. So what happens when we go to the next month? Well, Bob is going to owe slightly less interest. He doesn't owe the bank $210,000 anymore. He owes the bank $209,371.50. And so when we take 4.98% of that divided by 12, in month 2, Bob only owes the bank $868.89 of interest, which means a few more dollars out of the $1,500 payment are actually going towards the principal. And when we subtract this to find our new unpaid balance, I get $208,740.39. And we repeat this in month 3, and there are the numbers. And if we continue this for 16 years or so, Bob is ready to make payment number 200. He's still diligently paying $1,500 every month. And at this point, he actually only owes $67 in interest. And the large majority, most of his payment is actually going toward the balance at this point, so that after making his 200th payment, Bob only owes $14,728.33, and it's only going to take, a few more payments before Bob has paid off his 30-year mortgage early by paying more than the minimum monthly payment that was required. So again, just an overview of this chapter. The main concepts to understand are simple interest, compound interest, annuities, and loans.